Hi, dear children, good morning. In the last class, we explained the law of conservation of energy. Today, we are going to discuss a proof for law of conservation of energy. We already know law of conservation of energy means energy can neither be created nor be destroyed, but it can change from one form to another form. From this law, we can conclude a simple thing: the total energy will be a constant, because energy can neither be created nor be destroyed, but it can convert or change from one form to another. Suppose in the case of lighted candle, chemical energy converts to light energy and some heat energy. So the total value of that chemical energy will be equal to the sum of that light energy plus heat energy. So the law of conservation of energy, the basic concept of law of conservation of energy is the total energy will be a constant. Total energy will be a constant. That will be a same value. Okay. So here today we are going to discuss the law of conservation of energy in the case of a freely falling body. We know freely falling body means, suppose you have to take a ball to a certain height. Okay. Then this ball falls down. Can you follow me? Then that means the ball falls freely. Then what will be the energy changes takes place, and will it obey the law of conservation of energy? That fact today we are going to learn. Okay? The law of conservation of energy in the case of a freely falling body. Suppose I have a body or a ball of mass m. It is now placed at a height of h meter from the ground level. This is the ground level. Okay. Now think a ball of mass m or a body with mass m is placed at a height of h meter above the ground. Suppose I am considering this point as A. That means now the ball is at the point A. Can you follow me? I want to find out the total energy at that particular point A. Can you follow me? Please listen very carefully. I am explaining the fact with less speed, so you have to watch the video very carefully. Consider, or we placed a body of mass m at a height h meter from the ground level. We consider that point is A. we want to find out what is the total energy at the point A. So I will write here at A. At A, the body is not moving. That means the body is at rest. If a body is at rest, it possesses only potential energy. Okay? And kinetic energy is 0. So I will write at A, kinetic energy is equal to 0. Because body at rest. Can you follow me? Then the potential energy. Body is placed at a height h meter from the ground level. So definitely it possesses potential energy. To calculate the potential energy, we know the equation mgh. Here mass of the body is m and acceleration due to gravity is g and the height from the ground level, that is mgh. Then total energy is equal to potential energy plus kinetic energy. Potential energy is mgh plus kinetic energy 0, therefore mgh. That means the total energy at A is mgh. Can you follow me? Just listen. A body of mass m is placed at a height h meter from the ground level. We are considering that point is A. At A, the kinetic energy of that body is 0 because the body is at rest. Before falling, the body is at rest. And the body is placed at a height of h meter above from the ground level. Therefore, the body should possess a potential energy. We know the equation for potential energy. P is equal to mgh. And here mass of the body is m. And acceleration due to gravity is g. And the height from the ground level, that is h. Then potential energy is equal to mgh. Total energy is equal to Pe plus Ke, kinetic energy. Potential energy plus kinetic energy. Then the value of potential energy is mgh. And for the kinetic energy is 0. Adding both, we will get total energy is equal to mgh. Okay. In your text, for kinetic energy, we are using the symbol capital letter K. Okay. And in the case of gravitational potential energy, suppose the body falling freely towards the earth, then we can use U, that is the representation letter for potential gravitational potential energy. That means we can write the symbols K and U, capital letter U. That means U plus K. Anyway, you have to understand the total energy will be 0. Okay? That is the first part. That means at point number A, the total energy is mgh. Next, we have to listen. At any point on the following, the total energy should be mgh. And the next, the body starts to fall. The body starts to fall from the rest position or from that position h meter above the ground. Suppose we are considering while falling, the body reached here. That means the body reached or covered x distance. That means it starts to fall. Can you follow me? Body starts to fall from the point number A towards the ground, and it reaches a point. We are taking a point. Then the distance, suppose consider that point is capital letter B. Then the distance between that A and B, that is x. That means now the body covered x meter towards the earth. Okay? Then you know the total height, it is h, and this height is x. Then the remaining will be definitely h minus x. Okay? Is it clear? Okay? Okay. Now the body reached at the point M. Oh, sorry, B. The body reached the point B. Its mass has not changed, that is M. Before starting to fall or before starts to fall, the body was at rest. So its initial velocity u will be 0. Can you follow me? While falling, the body should have a velocity. That means its velocity is changed from 0 to another value. That means we have to calculate the kinetic energy and the potential energy at B. So at B, we have to calculate the potential energy or gravitational potential energy U, or you can write P, no problem at all. That is equal to equation we know, that is mgh. Then m is the mass, g is the acceleration due to gravity, h means that is the height from the ground level. Height from the ground level. Now we know it is the ground level, the point is B, then the height will be h minus x. Okay? Because the body covered a distance x, total height h, then the remaining distance will be h minus x. Therefore, we can write it as h minus x. mg multiplying or removing the bracket, mgh minus mgx. It is the value of that potential energy, gravitational potential energy. mgh minus mgx. Is it clear? Then we want to calculate the value of kinetic energy. Kinetic energy is equal to half mv square. We know the value of m, but we don't know the value of v. So we have to calculate the value of v firstly. Then we know one equation, v square minus u square is equal to 2as. Then here we have to calculate the v square. Minus u means it is the initial velocity that I have already told. Before falling, the body was at rest. So that is equal to 0 square. 2, a means acceleration. That is here acceleration due to gravity because the body falling towards the earth. Therefore, that is equal to g. And s means that is the displacement or the distance covered by the body. Body covers a distance x from A to B. Therefore, this is equal to 2gx. That means we got v square is equal to 2gx. Can you follow me? Okay, then we can write. We got the value. Then kinetic energy is equal to our equation is half mv square. Half m, we got the value of v square, that is equal to 2gx. 2gx. 2 and 2 and cancel. K is equal to, we got mgx. Okay. Then we have to calculate the total energy at B. That's equal to potential energy, gravitational potential energy plus kinetic energy. That's equals the value of U, mgh minus mgx. Plus the value of kinetic energy, that is equal to mgx. Plus mgx and minus mgx cancel. Therefore, the total energy will be mgh. That means at B also the total energy will be mgh. Okay? Just listen carefully. The body starts to fall. The body starts to fall from A. The body covers x distance. We took a point that is B. Then that will be a distance of, or that will be a height of h minus x from the ground level. So here we are calculating at B potential energy, that is gravitational potential energy, U is equal to mgh. Here mass, that is m, g acceleration due to gravity, that is g, and h means always that is the height from the ground level. So that is height from the ground level, that is h minus x. Then mg into h minus x. We have to remove that bracket. Then mgh minus mgx. We got the value of potential energy, that is U is equal to mgh minus mgx. Now we have to calculate the kinetic energy. Kinetic energy is half mv square. But we don't have the value of v. So we are going to solve the value of v. We know the equation of motion v square minus u square is equal to 2as. Here we need the value of v. U will be 0 because before falling the body is at rest. Therefore v square minus 0 square is equal to 2 into A means acceleration. Here body falling towards the earth. Therefore acceleration due to gravity g, and s is the distance covered by the body. The body starts from A and reaches the point B. The distance covered is x, so I'll write 2gx. That means I got the value v square is equal to 2gx. And again we are writing the equation for kinetic energy. Kinetic energy is equal to half mv square. Half m into, we got the value of v square, that is equal to 2gx. 2 and 2 are cancelled. We got the kinetic energy k is equal to mgx. Then total energy at B, that is gravitational potential energy plus kinetic energy. We know the value of U, that is mgh minus mgx, plus the value of mgx. That plus mgx and minus mgx cancel. Then we will get total energy is equal to mgh. And the body starts to continue to fall. We took a point B, but the body is not stopping there. The body is continuing to fall. That means the body reaches the ground. just touches the ground, consider that point is C. Okay, body just touches the ground. Can you follow me? That means just now body reaches the ground. Then also we have to calculate the potential energy and kinetic energy. Body reaches the ground. There is no height from the ground level. That means we can say that means at C, body reaches the point C. At C, our potential energy U is equal to, the equation is mgh. M is there, acceleration due to gravity, but h is equal to 0. That means that value is 0. Because there is no height from the ground level. Can you follow me? Okay. Then the value of potential energy, gravitational potential energy is equal to 0. And we have to calculate the kinetic energy, that is equal to half mv square. Same thing, we know the value of m but not the value of v. So again the same procedure as in the previous step. V square minus u square is equal to 2as v square minus u, before starting it is rest, 0 to a, that is acceleration due to gravity, into s, that is the distance covered by the body. Body starts from the point A and totally covered while reaching C, it totally covers a distance of h. Then it is equal to v square is equal to 2gh. Can you follow me? Then kinetic energy is equal to half mv square. That's equal to half m into value of v square, that's equal to 2gh. 2 cancel, that's equal to mgh. Can you follow me? Then total energy is equal to gravitational potential energy plus kinetic energy. Gravitational potential energy we got 0 and kinetic energy mgh, that's equal to mgh. Okay? At all the 3 points, at A, at B and at C, we got the same value. So we are saying total energy remains constant. In the case of a freely falling body, total energy remains constant.